Right, scrolling down. So, 2012 B1 now. A1. Newton's second law, what is it? Well, what's the formula? F equals ma. So you have many ways to say it. You can say it as, I think the easiest one just to say is force is the product of mass and acceleration. And just so you know, guys, product is a verb that means multiply. Force is the product of mass and acceleration. That's one way. The other way you're going to go for, Joshua?
Change in momentum.
Yeah, you could also go with or. Force is the rate of change in momentum. Yeah, rate usually implies time, but you can write it in time if you like. Okay, 1 mark secure. Part 2. Give an example of this. Anything. Gravity might be the easiest one. Yeah, something falling to Earth. Masses that fall to Earth. 1 mark. It's not. Go nuts, whatever you want. Okay. Next one here is calculate the impulse. What's the formula for impulse? Change in momentum. mv minus mu. What's the mass here? It's RFT, you're right. In this case it's actually, yeah, it's the FT one. Or it equals FT. Do we know the F? Yes. Do we know the T? Yes. Do we know the multiply? Well, even if you don't, you have a calculator. What's the unit? Newton seconds. Right. Part 4 is what is the effect of this impulse on the velocity of a stationary 2 kilogram mass? So what they're saying, if I try and draw this here, you have 2 kilograms at rest. Then what you do is you change its momentum. So now it's no longer at rest, but we'll say it's still 2 kilograms. What's the momentum at the start?
0.
0. And the momentum later? 2v, which will be 9.
V equals to 9 over 2.
Yes, which is then 4.5. So 2v equals 9, so v equals 4.5 meters per second. Part B. The 2 kilogram mass then continues to move at this velocity along a frictionless surface forbidden its collision. So what do we need for collision? Conservation of momentum. So the momentum before the collision, so it's 2 kilogram and what's the other one? 4 kilogram. And this is moving with 4.5 meters per second. And then this one here is at rest, is it? No. It's at 3, is it? And then they stick together to make 6 kilogram, and you would like the velocity here. So what's the momentum at the start? It will be 9 plus 12. And what's the momentum at the end?
But we don't know where they are moving that direction. Very good. Thank you, Joshua. This is actually moving, it says directly opposite, doesn't it? It's directly towards it.
Oh, there's...
M1 and
Hold on, there's some ambiguity about which way it's going. So let's read very carefully and put on our best English hats. The 2 kilogram mass then continues to move at this velocity along a frictionless surface until it collides with a 4 kilogram mass travelling directly towards it at a speed of 3. When I read that, it feels like it's telling me the 3 is heading towards the 4, so I should draw it like this, which just changes this plus to minus. And this here will be still 6v. Minus 3 equals 6v. V is minus 0.5 meters per second. So after the collision, the combination is heading to the left. So what you have is first block, second block.
How do you know that it goes to the left instead of right? Which impulse is bigger?
Hey dude! WTF? What are you doing here?
I wanted to see you very good at the side.
Alright.
So how are you? Yeah, I'm glad to see you.
Do you actually want to come in?
No.
No. What are you doing around here?
He's telling me I'm coming up and doing sense.
It's funny because for the last couple of minutes I felt like something wasn't right. Like there's some presence that's unsettling me. So you just come around and say, oh, teacher?
Yeah.
Unfortunately, these guys, they really need that physics revision. Actually, I'm just close to the door.
No, you can leave.
I'm actually in the middle of doing
Go, please leave. Okay, it's okay, you can leave. And we'll leave.
Well, anyway, we'll see you later. Yeah. It was good to see you then, okay? Try not to cause trouble, okay? Alright.
Mr. Ten, let's go.
What?
You can see the favorite students.
Yeah, favorite students. No, come on, work hard.
Would you?
And, you know, maybe this time next year, you two could be the students coming by the room right now, seeing the future class. Yeah. No. So I just saw someone doing something stupid at the window there, and then when I looked outside, I thought, oh, those two from last year. Not surprised. Okay, so what was he saying? Oh yeah, here. So the first block here, second block here, they're heading towards each other, but this one has more momentum than this one. So what happens is when they collide, they're going backwards. Think of a car and a bicycle. And when they collide, car wins. Yes. Please, down there. No trouble, please. Thank you. Right, that's part A done. Part B. Two men carry a straight wooden pole of length 8 and mass 16. One man holds the pole 1 meter from one end, the other 2 from the other end. Draw a diagram. Yay, drawing is fun. Here we go. So we have our pole. This is a mass of 16g, and then one man holds it here 1 meter from the end, and the other one is 2 meters from the end. So this is 1 meter. This is 2 meters. We don't know. We'll just call it R and S. We know that the pole is 8 meters long. So if it's 8 meters long, how much is this distance here? 3 meters. And this one here? 2. That meter really threw you off, did it? Right, draw a diagram. Done. Calculate the up forces. So we have R plus S equals 16g. And what's the other formula we use? The one with the turning force, yeah. So which one is the clockwise, the anti-clockwise? It's this one, and this one should equal this one here. So we have 1R plus 6S should equal 4 times 16g. So I have now R plus S should equal 16g. 156.96, and then here I have R plus 6S should equal 627.84. Okay, what's the best way to solve this? What method? Sorry, that is only for electricity. For here, elimination, just subtract them. So if I subtract them, I get 5s equals 470.88. So then divide that by 5, and I have or equals 94.176. Sorry, thank you. S equals 94.176. I substitute that back in to get the or now. So then or will equal 156.96 minus that answer, and that is 62.784. Done. Between what? They want the two upward forces. Okay. A weight is dropped from a height of 200 meters from a helicopter that is moving upwards with velocity 4. Calculate the velocity of the weight just before it hits the ground. Yeah. You know, when you're in situations that you're in a helicopter moving upwards at 4 meters per second, you release a ball. Okay, so what you have here, basically what they're trying to say is when the ball is released, it's actually going up with 4 meters per second. And it goes up and then down and hits the ground here. What else are we told? It's 200 meters. Okay, so this is UVATS. The U is 4. The V we don't know. What's the A? Yeah, the T we don't know. And the S?
200
S, what is it?
200 meters.
No.
200 something.
No.
No, the specimen is 100.
No.
9.8.
Minus 200. If you don't have the minus, you'll get it wrong. Because it's 200 meters below where it started, not above. If you did positive 200, you won't get any answer, because it's never 200 meters above where it started. It only moves up a little bit and then falls down.
But why is that minus 200? When it just moves a little.
It drops 200, doesn't it?
Dudes. We did this in class as well. Look.
Jesus.
No, hang on. No, hang on. Now, we did this in class. Remember, the S is displacement, not distance. So it is not 200 plus something. And displacement means position. If I'm calling up positive, I am because of the 4, and down negative because of the negative 9.8. The S, sorry, that's an S, not a T, is minus 200.
Oh, so we're taking 0 nothing down. We're taking 0 this.
Yeah, no, 0 is always the starting point.
Oh, okay.
So you need the minus 200 or you'll get the wrong answer.
It's the same as in projection.
If we use 9.8.
Yes, the one I did in class, the projectile on the cliff.
If we use 9.81.
Yes.
To be positive, to use S positive.
If you use 9.81 as positive, then the U is negative and the S is positive then, yes. You're just going into more trouble that way. Anyway, I want the V, so I can say V squared equals U squared plus 2AS. So V squared equals U squared, which is 16, minus 2 times A times S. But S is minus 200. So they'll both be positive. 16 plus 2 times 9.81 times 200.
Wasn't it negative 9.8?
Yeah, there, it's like that, it's the same thing. Square root that. So you get V is 62.8 meters per second. And then the last part is the time. So for part 2, the time, which formula should I use there? How about just...
V equals U to this.
Oh! No. Before I continue, there's one thing I need to do to fix my answer here. Minus. Because square root has a plus or minus. And sign is crucial here. It must be a minus because it's heading down when it hits the ground.
So it's minus.
So the answer is minus 62.8 is the velocity. Okay, so now we can use the formula V equals U plus AT, I think. So we get T equals just V minus U over A, which would be minus 62.8 minus 4 over minus 9.81.
But
6.81?
6.81.
Yes.
Everything horizontal. It should be formed this way.
Oh no, that's vertical. Because it says in the question the helicopter's moving up, not across. Now you're right. This could have been a question where the 4 was horizontal. Yeah.